I decided to do the review ones for worksheet or for review part 2 just because we don't have an extra day to review for that. Here's the key with these word problems. Take the time to actually read the question and understand what you're looking at here. Okay, so for this problem we're on a submarine in the Pacific Ocean. At time equals 0 we just make contact with the enemy destroyer. That does not mean at time equals 0 we are at our highest point or our lowest point or in the middle. I didn't tell you that. So do not assume that that is one of our key points in terms of that. That's just telling you when you are starting your movement. So we're porpoising, I can't say that word, going deeper and shallower. Now here is where the key points come into play. At t equals 4 minutes, you are at your deepest at negative 1,000 meters below, or which is 1,000 meters below the surface. So I'm gonna kind of just sketch a graph here, and I'm going to say I'm at 4, and I'm going to say I'm at negative 1,000 meters. So I know I'm there for my minimum. At time equals 9, you next reach your shallowest at negative 200. So that's the highest point that we're going to be getting on this problem. And that's all I give you. And assume that y varies sinusoidally with t. So that means it's going to be y equals with the t, like normal. Sketch one complete cycle. Well, hopefully you guys realize that this is not one cycle. This, if I draw the node line in here, is half a cycle. So we only have half a cycle. So we have to figure out, if it's a perfect sinusoidal curve, how to come up with our second time. Well, remember, it's symmetrical. So the next time that we're going to be down here at 1,000 from 4 to 9 is a distance of 5 minutes. So that means 5 minutes later we'll be back there, which means that and then we can find our midpoints too. At 11.5 we're in between, and at 6.5. So there's our graph. Basically, we need to get the midpoint here. Negative 12 divided by 2 is negative 600 meters. So this is a sketch of the graph. Again, your sketch probably will not include the 0 part. So I have all the pieces. Now we have one complete cycle. So the period is 10 minutes. So I'm going to start writing the particular equation right here. We have the graph that I just sketched out is going from t of 4 to 14. So I'm going to solve to get the guts of the problem. And remember, we want it to go from 0 to 360 because these curves have that as a period normally. And there's the guts. And we're in degrees for this one. So my equation is going to be negative. My amplitude is 400. It's a cosine curve that we made. 36 times t minus 4 degrees. And then our node line is at negative 600. So there we go. That is the equation. Now from this point, you just put this into your calculator and you plug in the values. So I'm not going to show you that part. I'm going to show you D though, because this is just doing the y1 of like 7, y1 of 11. So y1 of 7 you should get, it's at negative 476.393 feet. At 11 it's actually at the same spot, which makes sense because if you look at it, it's symmetric around the 9. So if you go to 7 or 11, it should be at the same depth, just because that's where it's symmetric around. We're 2 away from 9. Negative 76.393. And finally, the time at 15. I'm sorry, the depth at 15 minutes is negative 923.607 feet. Remember, if you're not getting answers that make sense in your problem also, like obviously these answers have to be between negative 200 and negative 1,000. If they're not, something's wrong. You're in the wrong mode. You did something wrong up here. Now, take the time to figure out what it is. If you're running out of time, then just do the problem with the equation that you got, okay? Your submarine is safe when it is below 300 meters. At time equals 0, was your submarine safe? Well, let's look at the graph of this. Actually, we don't need to go to the calculator because it tells us time is 0, so we already know the time. So let's just check and see what the time is when, or let's see what the depth is at time is 0. So we get time is 0, we get negative 276.393. Well, in order for our submarine to be safe, we have to be below that, which is more negative, which means like negative 350 or negative 400. So the submarine is not safe. Okay, right at time 0. But it's probably diving at that moment. So that's how you do one of these. So let's do one more real quickly. Now this one is tricky because of the wording, but again, it's all the same thing. There is a spaceship being launched from Cape Canaveral. We don't know how far away from the equator it is. It's not at the top, the bottom, it's at the North Pole, the South Pole, or the equator. Its distance from the equator, the ship, varies sinusoidally with time, and it's alternating north and south of the equator. So right now, the equator is going to be our node. Suppose that 8 minutes after it's launched, so I'm going to just make a curve here. And since I know that we're going to have a node of 0 for the equator, let's draw a line here. 8 minutes after the ship has launched. So again, the ship is not necessarily launching at the equator. It's launching somewhere. We don't know. But we do know that the ship reaches its maximum distance north of the equator. So let's call this north of the equator at 8 minutes. And now here's where people make mistakes. 40 minutes later, not at 40 minutes, but 40 minutes after what I just told you, which would be at 48. Okay. It reaches its maximum distance south of the equator. So just because it says maximum distance, it's maximum distance south, which on our graph will be the minimum. So we're down here. Okay, so again, I'm giving you half of a cycle. The distance between 8 and 48 is 40, so that means that we're going to complete our cycle at 88. And then in between these two, we get 28 and we get 68. So that means the points will be on that node line at the equator at those times. And there's my curve. I just sketched it. Ta-da! For these, you don't need a box if you don't want to, just because I'm giving you the information to plot, so you can think of it as that. Alright, so there's my curve. Write the particular equation. I don't tell you what letters to use here. By the way, always use the correct letters. Like up here, we used Y and T. Down here, it doesn't say. So I'm going to use T, and I'll use Y again just to be but if it was said use D, use D. It doesn't though. So we know our T is between, for this cycle, again, we're only looking at the cycle we just drew, 8 and 88. So we know that when we move the 8 over, and don't forget to move the 8 into the middle too. We get to here, and then how do I get from 80 to 360? Hopefully you guys figure out it's 4.5 or 9 halves. So okay. So the equation is y is equal to, I made a positive cosine. The amplitude is 3500. Remember, this number is from the middle to the top or bottom. Cosine of 9 halves t minus 8 degrees. And then plus 0. So you do not need the plus 0 if you don't want to. You can just leave it like that. So that is our equation. And here we go. We just have, again, y1 of 80 and y1 of 100. And you should get that the distance is, now specify north or south. So that means if you get a negative answer, you are, hopefully you realize, south of the equator. So if you type this in, you should get that you are that much north of the equator, 2831. And that's at what, 80 minutes? And then 100 minutes, you get 2057.248 kilometers north still. You're still north of the equator. Alright, how far is Cape Canaveral from the equator? Specify north or south. So, now I want to figure out where it is at time equals 0. Because remember, I said I launched at time equals 0 from Cape Canaveral. Cape Canaveral, I can't speak. So, let's find out what's happening here. We get y1 of 0, and you should get that Cape Canaveral is 2831.559 kilometers north of the equator. Hopefully you put north, because you should all know Cape Canaveral is, well, I'm guessing in Florida actually. Maybe you don't know, maybe I don't even know, but regardless, you should know it's in the northern hemisphere. Anyway, last problem. How long after it is launched does it take for the ship to reach the equator? The equator has a line of y equals 0. So that's all we know. So we're looking for where that hits. So I'm going to just get the calculator up, graph this, and see what's going on here. Real quick on the equation stuff. Make sure you close out cosine completely. Oh, what's going on there? There shouldn't be a 600 there, should there? Make sure you close out well, in this case it doesn't really matter because there's nothing following. But if you had a plus something or minus something, you make sure you have all the parentheses closed for cosine before you put that in, or it'll mess it up. So that's your equation. You can pause it there if you want to see it. The window should look like this. Now I'm starting at 0 to 88 just to see where Cape Canaveral is and where it launches off. You don't have to do a full cycle. I mean, you're using your calculator just to answer your question. And we want to see from the beginning for this problem. It says, how long after it is launched, so time equals 0, does it take for it to get to the equator? So I'm going to graph this. So there it is. It launched up here. That's where Cape Canaveral is in relation to the equator. And sure enough, you should find out that it's this node line here. And if you hit second trace 5, you should already kind of see that, well, it looks like it's going to be our 28 point that we actually had on our curve. So I hit enter, 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 and sure enough, it's at 28 minutes. So I would just say, how long after? It is t equals 28 minutes. And that's it. So really, the key is reading the questions carefully, making sure you just plot a cycle. Sometimes you have to create a full cycle, if I only give you half a cycle, and using that to come up with the equation. Again, most of the time you're not working at 0, you're working wherever I tell you you're working. And usually it's going to be cosine because I'm telling you a max and a min. Is it always going to be cosine? No. The tidal wave problem in worksheet 7 started at the level of the node, so it was a sine curve. But most of them will be cosine just because it's easier for us. But anyway, I hope this was informative, and I hope you guys do well on your test tomorrow.